Hi, and welcome to section J-4. We're going to look at perimeter and area of similar polygons. We have already looked at similar polygons in the sense of what's the scale factor. We've talked about the scale factor. If the length of one side is A and the length of the corresponding side is B, then the scale factor is A over B, or you could say it B over A, depending on which one you want to compare to the other one. So the perimeter, so the ratio of the perimeters is the A over B, but if we're dealing with area, A over B is not going to be the ratio you want to work with. Remember, area is square units, so it's kind of convenient that instead of just saying A over B, we use A squared over B squared. So that's how we're going to be dealing with the area of a similar polygon. We're going to find the similarity ratio, the A over B number. We're going to square it, and then we'll use that figure to find areas of the similar polygons. That's how the notes are going to work today. Let's go take a look at some examples. That'll be next. Here is one of the problems I want to look at. If you know the area of the smaller trapezoid, find the area of the larger trapezoid, and we're saying that they're similar. So the area of the smaller trapezoid is 27.5 square centimeters. So in order to do this, I have to actually know the similarity ratio of one to the other. I'm going to go ahead and say 6 over 9. So 6 over 9 is the similarity ratio of the smaller to the larger. Now I can reduce that. Let's go ahead and reduce that. It'll make the problem a little bit easier to do. That I can divide by 3, and I can make that 2 over 3. So the similarity ratio reduces down to 2 over 3. What I want to do is I want to square the A and the B value. So the similarity ratio of the areas will actually be 2 squared, which is 4, and 3 squared, which is 9. I'm going to use that similarity ratio when I want to find the areas. Now, since I know one of the areas, I'm going to set up a simple cross multiplication problem. Okay, so since 4 represents the smaller shape, I know the area of the smaller shape is 27.5. I simply need to cross multiply to find the area of the larger shape. So let's do that. 4 times x is 4x. 9 times 27.5, not sure. 9 times 27.5 is 247.5. And then last but not least, I'm going to divide by 4. X, which is the area, that's what I set x to be. Take 247.5 and divide it by 4, right? 4, yes. And we get 61.875. And now remember, that's area, so it's in meters squared. So there is our solution for that problem. Okay, let's try this one more time. This one's going to be a little bit trickier. This one's going to be the perimeter of the larger triangle is 47.8. What is the perimeter of the smaller and similar triangle? Well, we also are given the area of them. We want to find the perimeter of this one. So we cannot use these numbers in a cross multiplication problem. Instead, let's take and compare this to this. So 50 over 98, that reduces. Let's reduce that to 25 over 49. This is the similarity ratio of the areas, the area similarity ratio. So I need to turn this back into the perimeter similarity ratio. So this is already A squared over B squared. So in order to change it back to A and B, I have to take the square root of these. So the square root of that is going to turn into 5 over 7. The square root of 25 being 5, the square root of 49 being 7. So this is the similarity ratio. I'll write it down here, and this is the one I will set up my cross multiplication problem with. Now, I know the perimeter of the larger shape, so the 47.8 has to go down here with the larger shape, and my unknown value x is going to be this one. Let's cross multiply this. That's 7x equals 5 times 47.8, which is 239. And then we'll divide by 7, and x is 239 divided by 7, which gives me 34.14. And again, this is not area. This is actually the length of the perimeter, so that's not going to be a squared answer. That's just going to be in centimeters, 34.14.